Welcome to the Salmon Runs YouTube. Enjoy the video.
You start by securing compute and tooling. Get a GPU with CUDA support, set up Python 3, 8+, and install core libraries. Next, prepare a labeled dataset and immediately split into 70/30 train/validation so you can iterate without leaking test data. Pick a base architecture that matches your task, ResNet for images, Transformer for sequence tasks, and define initial hyperparameters like learning rate, batch size, and optimizer. Once done, save this baseline so you can compare improvements. Now build the training loop. Implement a data pipeline that handles augmentation, batching, and shuffling to improve generalization. Construct the model and include regularization like dropout and weight decay. Enable mixed precision to accelerate training on modern GPUs. Configure a loss function and metrics aligned with your goal. Train with practical callbacks, learning rate scheduler, early stopping, and frequent checkpointing so you can recover and analyze. Make sure to log experiments so you understand which changes move metrics. Finish by evaluating the model on a held-out test set, reporting precision, recall, F1, and calibration. This shows real-world readiness. If needed, optimize for deployment, prune weights, quantize to INT8, or distill into a smaller student model to meet latency and memory targets. Package the model in a container or model server, add monitoring for throughput and drift, and implement rollback. Troubleshooting tip. If performance drops in production, validate data pipeline consistency and input per process.
Thanks for watching. Consider subscribing if we helped you.